Here's where we're at. We have 12 class periods left. If I say 4 weeks, that makes it sound weird and horrible and yucky. But if I say 12 class periods, that makes it sound better. So 12 class periods left. I need for you to do something for me, please. And I'm going to share my screen so that you can see it. So before I can figure out exactly what these last 12 class periods are going to look like, I need to know about presentations. So if you go into Moodle, there should be in the homework submissions location a survey for you guys to fill out. It's a super easy 1-question survey. I just want to know what your preference is for your presentation, whether you'd rather do it live during class time via Zoom or pre-record it and then submit it to me somehow, either put it on Google Drive and share a link or submit it via Moodle if that'll work. You can't email it to me, the file will be too big. But if you could do this, please, sometime today or tomorrow, and I will also send out an email with this request after class for anyone who wasn't here. That'll help me plan how much time I need to allow during class for presentations and what I can do for teaching. So really quick, super easy, just submit that for me, please, and that will help me figure out what I want to do. So that's in Moodle, that's set up. Okay, that's the first thing. Second thing, remember that you are responsible for watching 5 presentations, however this works, and I will have a better idea of this on Wednesday when I come up with a schedule for you. So Wednesday, we'll have a better idea of what presentations are going to look like, etc., all that fun stuff. That's the second thing. Third thing, papers are due on Wednesday. I got a bunch of requests for approval of sources over the weekend. I think I replied to all of those. If I missed your email, please do send it again, but I think I'm caught up with everybody on email on approval of sources. So papers are due on Wednesday. We're going to say at noon because that's what we've been saying for homework submission times as well. So papers are due on Wednesday at noon. That slot is not set up in Moodle yet, but I will do that as soon as I get off of class today. So as soon as I finish class, I'll go ahead and submit a spot for you to submit, or set up a spot for you to submit your paper. Please, please, please submit it as a PDF, because then I can handwrite comments in like I did on your test, like I did on your homework. So if you wrote it as a Google Doc or as a Microsoft Word document, convert it to a PDF for me, please. You can convert Google Docs to PDFs, right? That's not a hard thing to do. Okay, good, thank you. So submit it as a PDF for me, please. That was the second thing. Questions on the paper? Anything last minute questions on the paper? Okay, if you send me sources to approve after 4 o'clock tomorrow, I may or may not get back to them tomorrow night. We will see. So don't be waiting until the last minute to send me sources to approve, please and thank you. Third thing, you should have gotten your homework back and you should have gotten your tests back. Nobody replied and said they couldn't read my handwriting. Did everybody get those? They did not get hung up in the WLC email. All right. This is one of the benefits of virtual class, that you can get your tests back faster than you would in real class time. But if I added up your points wrong, if anything looks weird on those, let me know. Otherwise, I was fine with how the test worked. If you have any comments other than me uploading the wrong test, sorry about that, we'll do better next time. If you have any comments, feel free to let me know, because we've got one more test, which is during the final exam. And I'm still thinking about whether I want that to be, it'll probably be at least somewhat cumulative, but it also probably won't be as long as a final exam. It'll probably be somewhere between a regular length and a final exam length. So that was thing number 3. Any questions on thing number 1, thing number 2, or thing number 3 before we do content? We're good.
For papers, are we supposed to have like headings for different sections?
It is up to you. You can decide whether you want to have headings for different sections or whether you want to just write it all the way in prose. So that one I am not super picky about. You can do either way, however you want. Yep, Daniel.
When we do the footnotes, do you want us, like, if we cite something more than once on different pages and we put, like the 2 there or whatever, do you want us to like write the source thing at the bottom of each page, or should we just do it like the first time and then?
You can shorten it. So you should do a full citation the first time, and then you can do a shortened one second time, like the author or whatever it is, the title and the page number, which is
Okay.
weird if you're doing online sources. Essentially, what I'm looking for, I am not an English professor. There's a reason I teach math. So essentially what I am looking for is for you to be able to cite sources in a way that I can find them. All right. And because your paper length is 3,000 to 4,000 words, it doesn't matter how you cite your sources and whether you're taking up space on the page or not. So that's a part of the reason that I have a word count instead of a page length also. Okay,
Thanks.
Elijah, yes.
So as far as the protocols for these different crypto systems go, since it's like a mathematical paper, do you still want to see like equations and possibly graphs and that sort of thing? I mean, it may not apply to everyone, but
Sure.
would that be something you'd be wanting us to include?
If you want to, if you feel like it's appropriate for your crypto system, then I would say yes, it is totally up to you. If you feel that's appropriate, you are more than welcome to include equations, graphs, etc. If you don't feel that it's appropriate, then you don't have to. Up to you, and it depends on, again, like you said, what type of crypto system you're thinking of, you're talking about. So, all right. Other questions on the paper? Good question so far. Anything else? Other questions on the paper?
Can we just like refer to Alice and Bob without like a ton of explanation?
Yes, stuff we talk about in class you can refer to. So Alice and Bob are very standard in cryptography. Carol is very standard in cryptography. You can refer to them. We know what public key cryptography is. We've talked about that a lot in class, so you don't have to explain that. If you have a specific question on something else, feel free to shoot me an email and ask. But the standard stuff that we've been discussing all semester, you don't have to explain in your paper. Anybody else? Other questions? Anybody, anything? Going once, going twice? Okay, so again, noon on Wednesday, and I will get a slot set up on Moodle for these to be submitted as soon as we're done with class today. All right, so here's the plan-ish, kind of, sort of, because I don't know exactly what the plan is because I need to figure out how much time I need to allow for presentations. But we're going to move on today to talking about hash functions. So this is kind of the next topic that we're going to talk about. We're going to move on to hash functions, and then after that, we'll see where we are going. I haven't yet figured out where we're gonna go after hash functions, but I've got at least 2 or 3 class periods on hash functions. So this will give us a little bit of time to talk through some stuff while I figure out the last part of the schedule. So hash functions, here we go. Basically, these are used to make crypto systems and signature schemes faster and more efficient. There is an added level of security also that you can get with hash functions, and there are kind of 2 different types. There are hash functions, and then there are message authentication codes. If we have time, we're going to talk a little bit about message authentication codes. The reason I want to talk about that is because that's my graduate school research. Like, this is what I did in grad school, and my dissertation, now again, you have to remember that I'm a very theoretical cryptographer, okay? But my dissertation in grad school was creating a new message authentication code. So if we have time, if I can find my slides, I might talk through that in a class period, and you might get to see my grad school research. We'll see. It's been a while. I have to make sure I remember what's happening with it also. But 2 different basic types going on here, hash functions and message authentication codes. There are a whole bunch of different subcategories under each of those, but those are kind of the 2 broad overarching categories. So hash functions first. These are usually denoted by a function, either capital H or lowercase h. So that's usually the notation. And here's how this function works. It takes as input a message of arbitrary length. And the arbitrary length is really, really, really important. Hash functions need to be super, super flexible. You have to be really flexible with these. So you want to be able to take a message of any length that you want and input that message. So that's your input. And then your output is a string, a character. You can be letters or characters, either way. And this is going to be fixed length. And since this is a function, our input is m and our output is h of m, right? It's a function, you've got an input, you've got an output, just like every other regular normal function that you have. So those two requirements are super important, and those are going to be things that we're talking about as we go through hash functions over and over. Arbitrary length input and fixed length output. Really, really important. Both of those are crucial for hash functions. Arbitrary length input, fixed length output. Sometimes the output is called a hash value, but sometimes it's called a message digest also. So that's another name for the output of a hash function. Sometimes it's called just a hash value. Sometimes it's called a message digest, just another name. So here's your basic idea. This is what we're looking to do. We want to take really long messages and we want to compress them into a shorter string. That's the basic idea of what's going on with a hash function. We'll talk about why hash functions are useful after we get through the technical requirements and where these get used in practice, but this is the basic idea. Take something of arbitrary length input and produce something of fixed length output, and that fixed length output should be way shorter. That's the basic idea, okay? Basic idea. There are requirements for a hash function besides these two that I keep harping on. There's a couple other ones. So 3 big requirements for hash functions. You can kind of think of it as 4 if you go back to arbitrary length input, fixed length output. But here's your requirements. First one's called ease of computation. That's the first one. Ease of computation. This is a list that you should have memorized, by the way. We're going to get into this an awful lot. Ease of computation. So what that means is, given a message, it's easy, and remember what easy means in computer science terms. That means fast. So easy and fast to compute the hash value h of m. That's your first one. Given a message, it's very easy, very fast to compute the hash value h of m. We've talked about operations that are fast and slow up to this point, right? So addition, subtraction, multiplication, those are all fast. Those are good. Exponentiation is slower, especially if you are doing power mods. This is not a fast operation. So we would like to try to stay away from exponentiation in hash functions. We're going to talk about an example of a hash function probably on Wednesday that's called SHA-1, and we'll look at the specific operations that occur in there and talk about why those are all fast as well. But in general, right now, addition, subtraction, and multiplication, those are all fast. Exponentiation with the mod is slow. So we want to avoid exponentiation. That's the first one, ease of computation. Second one is called pre-image resistance. That's my second one, pre-image resistance. That's the second requirement. What this means is, given an output, capital X, it is hard to find an input, M, so that your hash value is equal to capital X. So given an output, capital X, it's hard to find a message that hashes to that output. Pre-image resistance. If I give you an output, it's hard to find an input that it came from. Or in mathematical terms, and this is pre-image resistance, right? Given an image, it's hard to find the pre-image that it came from. That's mathematical terms. If you think about functions, images, and pre-images. So given an image, it's hard to find the pre-image that it came from. Pre-image resistance. Third one is called strongly collision-free. Strongly collision-free is my third requirement for hash functions. So this one says that it is hard to find two messages. We're going to call them M1 and M2. So hard to find two messages where the messages are not equal, but the hashes or the outputs are the same. It's hard to find two messages, M1 and M2, where the messages are different, but the hash values are the same. Strongly collision free. So the collision that we're talking about would occur if your hash values are the same. We're trying to avoid finding a collision. So we want this to be strongly collision free. M1 and M2 have to exist. And the reason for this, if I were doing this in class, I'd split you up into groups and you talk about it, but we're not. M1 and M2 have to exist because we're talking about a function with arbitrary length input and fixed length output, right? So since there's fixed length output, there's only a finite number of choices for your output. Arbitrary length input means there are infinitely many choices for your inputs. So therefore, there have to be two of these inputs that are going to output to the same hash value. They have to exist. What we want this function to be is something that's hard to find them. That's what we're looking for. Danielle, question. If anybody else has a question, you have to raise your hand virtually. I can see some.
Yeah, I know. I would answer. What's it like? Because there's also like weekly collision free.
Yes, that is the next slide.
But does that not? Oh, okay.
Yes, so hang on to that question for weakly collision free, just 1 second. So these are the ideal requirements for a hash function. This is what we would like if everything is fantastic and we were designing the best possible hash function that we could. This is what we're looking for. Ease of computation, pre-image resistance, strongly collision free. Any other questions at this point in time? How are we doing? Good? Okay, I'm gonna pause the recording because it's getting long and